Today we're going to look at scatter plots and correlation and best fitting lines. A scatter plot is when you have a graph with a whole bunch of points on it and the points are scattered, hence the name scatter plot. If the scatter plot shows positive correlation, our points would be scattered, but it would generally look like they had a positive slope. Like if you stuck a line through those points, that line would have a positive slope. Negative correlation happens when the points tend to have a negative slope. So they start up here and they're kind of scattered, but generally if you put a line to those points, it would have a negative slope. Relatively no correlation happens when the points are so scattered that if you tried to put a positive line on it or a negative line on it, you could say that either one, here I'll make this even more, there we go. Both a positive line and a negative line could fit because basically neither of them fit. So that is no correlation. If we have a scatter plot with decent correlation, if the points are fairly clustered around a line, we can draw a best fitting line. And there's 4 steps here that we need to follow. We're just going to dive right in and do this. So, draw a scatter plot of the data, then approximate the line for the data. First, I want to look at the data to decide if we need to change the scale of our graph at all. It looks like we've got negative x values, positive x values. So it looks like negative 10 to 10 is still the best. Yeah, I think that's the best. And then the y values, negative 10 to 10 looks to be about the best. So we're going to have the middle be 0, 0 like normal. So the point negative 4, 8. We need to plot the point negative 4, 8. Negative 4, 6, 7, 8. Negative 2, 5. 0, 5. 2, 4. You can pause the video so you don't have to keep listening to me. I'm going to pause the video and finish plotting these points. Once we have the points on there, we need to draw a line that best fits this data. Now, I'm going to put my ruler up here. You really do need to use a straight edge for this because if you approximate a line, it's not going to be a straight line and it's going to be awful. Okay, for a minute, I want you to not draw anything on your graph. I'm going to draw a couple of lines and I want you to tell me if you think that the line fits the data. Does that line fit the data? Why not? It's not touching any of the points. All of the points are above the line. Does the slope of the line look about right? The slope of the line looks pretty good, but it's not in the right position. So you're trying to get a line that fits within the points. This is kind of weird. You don't want to go through the points that are there, but you don't want to avoid going through the points that are there. So don't draw the line through the points, but don't not draw it through the points. Does that make any sense whatsoever? Okay, so as you're kind of putting your straight edge through here, you want about the same number of points above and below the line. So it's nice to have a clear ruler. Like, do you see how you can kind of see through this ruler a little bit? So 1, 2, 3, 4, there's about 5 points above. 1, 2, 3, 4, there's about 5 below. In between points that are there, you want to kind of equalize the space. So like this point right here is pretty far away from the line that I currently have, but then on the other side, there's a couple of points that are pretty far away, about the same amount of distance away. Does that kind of look like a good line? Okay, so I'm going to draw that line in. Here's what I mean. I didn't try to hit any of the data points, but if the line goes through a data point, that's okay. So don't try to make it hit a point, but if it hits a point because that's the line that seems to fit, that's fine. Now here's the really frustrating thing about today. The chances of you drawing in the exact same line that I drew are very, very, very rare. We could calculate the probability if you wanted to. We could do a quick little probability unit. You guys want to do that? No? Okay. That is later. So from this point onward, our work is likely going to look different because your line and my line are different. And once we get to the end, we'll see how similar our equations are. Your next step is that you need to pick 2 points on your line. So I am not going to pick this point because it's not actually completely on the line. The line just kind of skirts the edge of it. But I think this point right here is on the line. And then I don't want another point too close, because if I use this point right here, that's too close. That's going to skew what my slope is. I want something more down like right here. It is a really good idea to not use any of the original data points. Pick points that are actually on your line, not points that were originally given to you. So my points are -3, 9, and 6, -2. Your points are likely different because your line is different. So pick 2 points. They don't have to be the same as mine. Once we have 2 points, based on what we learned yesterday, what do you suppose we're going to do with those points? We are going to find the slope. And then we're going to put the points, or one of the points and the slope into point-slope form. And then we're going to solve it down and get to slope-intercept form. So I'm going to find my slope. Take a moment and find your slope. And you can use a decimal because this is not going to be a pretty number. It's likely going to be something kind of crazy. Your slope should be negative, so if you get something that isn't a negative slope, you probably did something wrong. Once I have my slope, I'm going to pick one of my points, and I'm going to plug this all into point-slope form. So mine is y minus a -2 equals -1.22 times x minus 6. And then I would distribute. There is actually a way for a graphing calculator to calculate the true line of best fit. So what I would do on a test is like this one, according to a computer program that finds the true line of best fit, it should be -1.09x plus 4.8. So if your slope is anywhere between, I'd say, -0.9 to -1.8. If your slope is somewhere in that range, you've got a good slope. If your y-intercept is anywhere between, I'd say 3 to 7, you have a good y-intercept. So look at your line. Is your slope somewhere in between negative 0.9 and negative 1.8? Is your y-intercept somewhere between 3 and 7? Then you've got a good line. Okay, so let's go over this process again. I don't know that we really need to do this again, but I want to kind of go through the process. Plot the points as accurately as possible. Draw in a line that you feel fits the data. If I were to draw in a line like this, look at that pink line. There's about the same number of points above and below, but does the slope match those points at all? No, so that's not a line that fits the best. So try to get a line worked in there that has about the same number above and below, equalizes the space. Don't try to hit original points, but don't really avoid them either. Once you have a good line in there, pick 2 points that are on your line. Not original data points, but points that are actually on your line that you can get the coordinates of. Once you have those 2 points, it's exactly like yesterday. Find your slope. It might be a crazy decimal, and that's okay. Plug your slope and one of your points, not an original point, one of your points into point slope form. Get it into y equals mx plus b form, and then you're good to go. Take a look at the next example. I just want to talk to you about the potential need to change scale, because it's really going to be easiest for you if your scale matches your data. So take a look at these values. What's the smallest x value? I think negative 2 is the smallest x value, and the largest x value is 5. So do we really need to go from negative 10 to 10 if our values are only from negative 2 to 5? So we could say that this is 1. I should do that in black so it's easier to see. This is 1. This is 2, 3, 4, 5. And when I look through here and I see that some of my data values are 0.5, that's going to make graphing those 0.5s a lot easier if we change the scale. So then over here we've got negative 1, negative 2, negative 3, negative 4, negative 5. You don't have to do the same scale on the x and the y axis, but in this case it looks like it might be the best. Our biggest y value is 4 and our smallest y value is negative 2.5. So doing that same exact scale on the y-axis would be helpful. Then you just have to remember that every box on that graph is 0.5. So when you're graphing like this point right here, 0.5 to 0.5 would be right there. So one more time, plot your points accurately, use a straight edge, draw a line in that you feel fits the data, about the same number of points above and below, match the slope, equalize distance. Don't try to hit points, but don't avoid points either. Pick 2 points that are actually on your line, find your slope, use your slope and one of your points in the point slope form, and then get it into y equals mx plus b.